In genetics, pedigrees are a very common tool used to display the patterns of inheritance for traits and/or diseases throughout a family. To demonstrate how they work, I will be examining the characters from the hit show Grey's Anatomy. One of the most significant plot lines from the beginning of the series surrounds Meredith Grey and her struggle in helping her mother, who suffers and ultimately ends up losing her battle to Alzheimer's. Meredith becomes very determined to have her genetics tested to see if she is a carrier for the disease. I will be looking at Meredith's specific family pedigree to explore her chances of being a carrier and potentially passing on this trait to her children by determining the inheritance pattern of the disease. To understand how Alzheimer's could be passed down to Meredith and how pedigrees work, the patterns of inheritance must be understood. An X-linked dominant trait occurs when the gene responsible for a trait or disorder is located on the X chromosome. Males and females can both display this trait with only one copy of the gene present. A common indicator for this type of inheritance pattern is that an affected father will have affected daughters. X-linked recessive patterns of inheritance also occur when the gene responsible is located on the X chromosome. However, females need 2 copies of the gene to present the trait or disorder, whereas males only need 1. Autosomal dominant patterns of inheritance occur when the gene responsible is located on an autosome, meaning a non-sex chromosome. What makes this special is that only one gene is necessary for the specific trait or disorder to be present. Autosomal recessive patterns of inheritance also occur when the gene responsible is located on autosomes, but to present the trait or disorder, 2 genes are necessary. If only one gene is present, the person is a carrier. Y-linked patterns of inheritance occur when the gene responsible for the trait or disorder is only present on the Y chromosome. Since only males have a Y chromosome, inheritance is only from father to son. This pedigree displays Meredith's family and the inheritance of Alzheimer's. Although the show does not specify whether she will develop the disease, for the purpose of this pedigree, we will say that she does. Meredith inherited the gene coding for Alzheimer's from her mother, but her father did not have the gene, so she is heterozygous. But because she was still affected, it can be determined that Alzheimer's is a dominant gene. Meredith also married someone that is not affected by the disease, so each of her children will receive one recessive allele from him, but because they are young, it is not determined whether they receive the dominant or recessive allele from Meredith, so their genotype is unknown, but they have a 50% chance of being carriers from their mother. Since the inheritance of Alzheimer's is not limited by sex, the disease is not X or Y linked, and because only one copy of a dominant gene is needed, the inheritance must be dominant.